Welcome to Thought Frontier.
Welcome to another deep dive.
Oh, this is exciting.
So we're going to kind of rewind the clock today
Yeah.
and take a look at how we got from, like ancient myths to algorithms that can practically write poetry for us now. It's wild.
It really is. It's incredible to think that this yearning for artificial intelligence, it goes back centuries, right? I mean, we're talking ancient myths like Talos, the bronze giant, stomping around Crete, shucking boulders at ships.
Like the OG Terminator.
Uh-huh, yeah.
Just made of bronze.
Right, a little less existential angst.
Yeah, exactly.
But it really shows you this desire to create artificial beings, things that can think and act, maybe even feel like us.
Yeah.
It's ingrained in human storytelling, isn't it? It's about our curiosity, our need to understand ourselves by trying to recreate ourselves,
Yeah, that makes a lot of sense.
Yeah.
But it wasn't all just myths and bronze giants, right? Eventually, this whole idea of artificial intelligence got a little bit more, scientific.
Yeah, for sure.
A lot more.
A lot more.
So how did that happen?
Well, you had philosophers like Leibniz, right? He was already playing with this idea of a universal language, a way to kind of reduce all reasoning to a calculation.
Oh, wow.
Then came the real game changers, the breakthroughs in mathematics and logic, things like the Turing machine.
Okay, wait. So for people who might not be familiar, the Turing machine, it wasn't like a physical machine.
No, not at all. It was a theoretical concept.
Okay.
More of a thought experiment.
Oh, okay.
But it was totally revolutionary.
Yeah.
Because it proved that any problem that you could break down into like a set of logical steps,
right,
it could, at least in theory, be solved by machine.
Oh, wow.
So it planted the seed, Yeah.
What if thought itself could be turned into a kind of code?
Oh, that's fascinating.
Then maybe a machine could think.
Whoa.
And then that brings us to actual computers.
Oh, yes. The real deal.
The big, the behemoths,
Yeah.
born out of wartime necessity.
Absolutely.
You had things like the ENIAC, for example.
Right.
It proved that really complex calculations, they could be done at speeds that humans couldn't even dream of.
Yeah, that's amazing.
So suddenly, this idea of creating a thinking machine, it wasn't just theoretical. It felt, achievable.
It felt real.
It felt real, yeah.
And all that buzz, all that possibility.
Right.
It really kind of culminated in that famous 1956 Dartmouth workshop, right?
Yeah.
The official birth of AI as a field.
Exactly.
This wasn't just any conference. It was like the Avengers assembling for the first time.
That's a great analogy.
Perfect, right?
Yeah. You had, all the big names, Minsky, McCarthy, Newell, Simon. They were all there.
And they were so optimistic.
I bet.
I mean, they genuinely believed that we would have machines that were as smart as humans within a generation.
Whoa, that's some serious confidence.
Oh, yeah.
Well, I mean, when you're surrounded by that kind of brain power,
right,
it's easy to get a little carried away, I guess.
But, they weren't just theorizing.
Yeah.
They actually had some early successes.
Oh, really?
Like programs that could solve algebra problems.
Wow.
Even prove mathematical theorems.
No way.
Yeah. It really felt like the sky was the limit.
But then things kind of took a turn, didn't they?
Yeah.
That initial euphoria gave way to the, what do they call it? The first AI winter?
Yep.
So what happened? Did they just hit a wall?
Well, more like a series of walls.
Oh, no?
One was just raw computing power,
Yeah.
The problems they were tackling, they turned out to be way more complex than they'd anticipated.
Oh, I see.
Take the combinatorial explosion problem, for example.
Okay, I've heard of that, but explain it for our listeners who might not know.
Sure. So, imagine you're trying to find the best route on a map, right? But instead of just a few streets, there are millions of possible paths.
Oh, wow.
The number of possibilities just explodes exponentially, and it makes it super difficult to solve, even with powerful computers.
So the computer just gets bogged down?
Basically. And then you also had things like Moravec's paradox.
Okay, yeah, I remember that one.
This was the observation that things that we humans find easy, like recognizing faces or navigating a room.
Yeah, that's easy for us.
Those were surprisingly difficult to program into computers.
That doesn't make sense, though. So computers were better at, chess.
Right.
Than, walking down the street without bumping into things.
Yeah, pretty much.
How is that even possible?
Well, that's what's so fascinating about Moravec's paradox.
Yeah.
It shows us how much of our intelligence is subconscious and intuitive, right?
Yeah.
Things that we do without even thinking about it, they're actually the result of millions of years of evolution.
Oh, wow.
So replicating that in a machine, that turned out to be incredibly difficult.
It's like we take our own intelligence for granted.
Yeah.
Until we try to teach it to a machine.
Exactly.
Yeah.
That makes sense. And then there's also the whole issue of common sense knowledge.
Oh, right.
I mean, imagine trying to program all the things that you just know instinctively.
Yeah.
Like, that water is wet, fire burns, how to have a conversation, all that.
All that stuff we just kind of know.
Just this massive amount of information, and they had no idea how to represent that in a way that a computer could use.
It's like a whole other level of intelligence.
Totally. So it wasn't just these technical hurdles, you know.
Oh, right. So what else is going on?
The funding for AI research, that started to dry up too.
Really?
Yeah. Government agencies like DARPA,
Oh, yeah.
which had been like major funders of AI research,
Mm-hmm.
they started to pull back because they wanted to see, you know, more tangible results.
So they wanted to see some return on their investment.
Basically. And the progress just wasn't there yet.
So it's like everyone was expecting a rocket launch,
Mm-hmm.
and they got, I don't know, a sputtering engine instead.
Yeah, pretty much.
So what happened then? Was AI just put on ice? Did everyone just give up?
Not quite. While funding for these big, ambitious projects, you know, kind of dwindled,
Right.
there were still some pockets of activity.
Oh.
Researchers were exploring new approaches, and even during this so-called AI winter, you know, the seeds were being sown for the next AI spring.
Oh, really? So it wasn't a total shutdown?
No, not at all. And let me tell you, that next chapter,
Yeah.
it gets really interesting.
Oh, I can't wait to hear about it.
Yeah, it's a wild ride.
Well, I think we're just getting started, listeners.
For sure.
And it sounds like things are about to get really exciting.
So one of the most fascinating things that happened during this time was the rise of expert systems in the 1980s.
Oh, yeah, expert systems.
Yeah, so instead of trying to create, you know, like a general intelligence,
Right.
researchers focused on AI that could, like, excel in very specific domains.
So this is where AI gets practical.
Exactly.
It's like, forget building a robot that can do everything.
Right.
Let's just make one that's amazing at diagnosing diseases.
Yeah.
Or identifying, like, I don't know, chemical compounds or something.
Exactly. And you know what?
Yeah.
These systems, they were surprisingly effective.
Really?
Yeah, like you had Dendrol, for example.
Okay.
It could analyze mass spectrometry data
Oh, wow.
and actually determine the structure of organic molecules.
That's pretty impressive.
It is. And then there was MYCIN,
Okay.
which was like a pioneer in medical AI.
Oh, good.
Could help doctors diagnose bacterial infections.
So they were showing that AI could have real-world value, even if it wasn't like the all-encompassing intelligence that people had initially imagined.
Exactly. It really was a big deal.
Yeah, this must have been like a huge boost for the field.
Oh, absolutely. It sparked this resurgence of interest, even an AI boom, you could say.
Wow, so things were looking up again.
Yeah, for a while, companies started investing heavily. Governments launched these ambitious projects like
Oh, like what?
like Japan's 5th generation computer project.
Oh, yeah, I've heard of that one.
Yeah, it felt like AI was, you know, back on track to change the world.
But if I remember correctly, there's another AI winter coming.
Okay.
Right.
Oh, yeah, unfortunately.
So what happened? Did the expert systems just, like, hit their limits?
Well, in part, yeah.
Okay.
I mean, they're expensive to maintain, hard to update, and they couldn't really learn or adapt to new situations, you know?
So they were kind of rigid.
Yeah, exactly. And then plus, you had the personal computer revolution happening at the same time.
Yeah.
And all these specialized AI hardware companies, they kind of found themselves outpaced by these, like, readily available desktops.
Oh, wow. So technology can be pretty ruthless.
It really can. One minute, you're at the forefront of innovation.
Yep.
The next minute, you're yesterday's news.
It's a fast-moving world.
It is.
But even during the second AI winter, I feel like there was this quiet revolution brewing.
You're picking up on the pattern here.
Yeah, maybe.
But this time, it wasn't about, you know, like flashy headlines or grand pronouncements.
Yeah.
AI was quietly becoming like this indispensable part of our technological infrastructure.
Oh, interesting. So while the spotlight had faded, AI was infiltrating industries, kind of working behind the scenes.
Yeah, exactly.
That's fascinating. Give me some examples.
Well, think about things like data mining,
Oh, okay.
logistics, banking software,
Right.
even those early search engines that were starting to pop up, you know?
Yeah.
AI was being used to optimize processes, personalize experiences, and make sense of this ever-growing flood of digital information.
So AI was becoming this like hidden engine,
Yeah.
powering so much of our digital world, without most people even realizing it.
Exactly. And this period of like quiet integration, it was actually crucial for AI's long-term development.
I bet. It's like it was getting all this real-world experience under the radar.
Yeah. It allowed researchers to, refine their techniques, solve actual problems, and really build this solid foundation for the next major breakthrough in AI.
Okay, so now I'm really intrigued. What was this breakthrough?
Well, it was this perfect storm of like big data, faster computers, and a completely revolutionary approach to machine learning.
Oh, really?
Yeah, an approach known as deep learning.
Ah, deep learning. The rock star of modern AI.
Exactly.
This is where things get really mind-bending.
Yeah, we could say that.
So tell me more about this deep learning.
Well, so deep learning uses these artificial neural networks.
Okay.
But with many, many layers. So think of it as giving AI like a much more sophisticated brain, right?
So it's like taking those early neural networks, which were kind of basic, and giving them a serious upgrade.
Exactly. And with this new brain, AI could learn from massive amounts of data in ways that we never thought possible.
So what kind of results were they seeing with this deep learning?
Oh, the results were astounding. Deep learning systems started to outperform traditional AI in all sorts of areas.
Like what?
Like image recognition, speech processing, natural language understanding.
Wow, so AI was starting to see and hear and even understand language.
Yeah, pretty much. And with remarkable accuracy, too.
That's incredible. I remember hearing about ImageNet, this massive database of labeled images.
Yes.
Was that important for deep learning?
Oh, ImageNet was huge. It was a total game changer.
Yeah.
By training deep learning models on this massive data set, researchers were able to achieve these like significant leaps in image recognition.
That makes sense.
And then you had word-to-vec.
Word-to-vec, okay.
This was a model that could actually represent words as like numerical vectors.
Okay.
Capturing their meaning and their relationships to other words.
So instead of just seeing words as a bunch of letters, AI could start to grasp their underlying meaning.
Exactly.
That must have opened up a ton of possibilities.
It did. It paved the way for all the incredible language models we have today.
Oh, wow.
Models that can, like, generate text, translate languages, answer your questions, even write code.
It's crazy how far things have come.
It really is. It's a truly transformative period in AI history.
And speaking of transformative, I can't wait to hear about those modern language models.
Yeah.
And how they're blurring the lines between human and artificial intelligence.
It's getting really interesting.
It is.
Deep learning changed everything.
It really did, but it feels like that was just the beginning, right?
Oh, absolutely.
Things have gotten even wilder in the past few years.
It's an explosion.
It is.
Large language models, ChatGPT.
Right.
Yeah. And these are practically household names now.
They are. It's crazy. So where did this all come from?
It all boils down to this brilliant piece of engineering called the transformer architecture.
Okay, the transformer architecture. So break that down for me.
Okay.
What's so special about it? I'm picturing like Optimus Prime trying to write a sonnet.
Well, maybe not quite like that.
Okay.
Think of it this way.
Okay.
Transformers are incredibly efficient at processing language.
Okay.
They can analyze whole sentences, even entire paragraphs,
So not just like word by word.
Exactly. Not just individual words.
Got it.
This lets them really capture the context and meaning in a much deeper way.
So it's like giving AI a superpower for understanding language. Okay, that makes sense. So no wonder these large language models are so good at like writing and translating, even coding.
Right. It's amazing what they can do.
It really is. And they're trained on these massive data sets.
Massive. I mean, we're talking practically the entire internet in some cases.
Whoa, the whole internet.
Yeah, and that's what allows them to produce this like incredibly human-like text.
It's mind-blowing. I mean, I've played around with ChatGPT myself.
Yeah.
It's pretty impressive, I gotta say.
It's pretty amazing.
But there's still this debate, right?
Yeah.
Are these models truly intelligent? Or are they just really good at mimicking intelligence?
That's the million-dollar question, isn't it?
It is.
Some experts were pretty skeptical at first. They saw these models as like glorified pattern matchers. But even the biggest skeptics, they've been blown away by this latest generation of LLMs.
Really?
Oh, yeah. ChatGPT-4, for example, it can pass these really advanced exams, even in fields like biology, which requires a pretty deep understanding of, complex concepts.
So are we getting closer to what researchers call artificial general intelligence?
Ooh.
That holy grail of AI that can, like, learn and reason just like a human.
It's starting to feel that way.
It is.
Yeah, I mean, Microsoft Research, they even published this paper suggesting that a model like ChatGPT could be considered like an early, incomplete form of AGI.
Wow. Okay. That's a pretty bold statement.
It is. I mean, AGI was practically science fiction just a few years ago.
It was.
And now it feels like it's right around the corner.
It does, which is exciting.
Yeah.
But also kind of scary, to be honest.
Well, yeah, that brings up some big questions, right?
Like what?
Like, how do we make sure that these increasingly powerful AI systems, how do we make sure they're aligned with human values?
Oh, right.
And how do we prevent any unintended consequences?
That's what researchers call the alignment problem, right?
Exactly. It's like making sure that this super intelligent AI doesn't just decide that we're obsolete.
Oh, yeah.
Or, I don't know, accidentally turns the planet into a giant paperclip factory or something.
And those are some scary thoughts.
I know, but it's a real challenge that researchers are taking very seriously.
That's good to hear.
Yeah, organizations like DeepMind and OpenAI, they're explicitly focused on developing AGI safely and beneficially.
So there's hope.
Yeah, there's definitely hope. But there are no easy answers, and this is a conversation we need to be having as a society.
Absolutely. It feels like we're at this, like, incredible inflection point in history.
It does.
We have this unbelievably powerful technology with the potential to, completely reshape our world.
Yeah.
But we also have this responsibility to guide its development wisely.
It's exciting and a little terrifying all at the same time.
It is.
Yeah.
And that's what makes this field so fascinating.
Yeah.
So after this deep dive into AI history, where do you think things are heading?
That's a great question.
Are we on the verge of, like, a new era of intelligence? One where humans and machines collaborate to solve our biggest challenges?
You know, that's a question for all of us to think about, isn't it?
It is.
But one thing is for sure.
What's that?
The future of AI is being written right now, and we all have a role to play in shaping it.
Well said. This has been an incredible journey through the history of AI.
It has.
It's a story of ambition, ingenuity, setbacks, and, ultimately incredible progress.
And it's not over yet.
It's not over yet. So to all our listeners out there, keep exploring, keep questioning, and keep imagining, because the future of AI, well, it's in our hands.
That's right.
Thanks for joining us on this deep dive, and until next time, keep learning.